non-parametric statistics. And for this topic, we are going to discuss two situations where we have one population and how about if we have two population to deal with in making our inference using statistical, what we call sample evidence, and to make decision for our population parameter. Now, unlike in what we have our discussion in parametric equation methods, we have discussed about how we can use population means and population proportion using the sample mean and sample proportion to make decision for the population mean and population proportion. Now, unlike what we have in our previous discussions, non-parametric statistic would be a bit different in terms of what we are testing. Okay, so there will be two tests that we are going to look at. First, for one population, there will be sign test, and for the two population, we are going to discuss for the man-with-me test. Okay, so what will be the difference between the two? Okay, in making our statistical inferences, okay, for our previous part, we have discussed on how we can make what we call statistical inference using our confidence interval, okay, using our confidence interval for one population. And on the one population, we discuss on how we can use the population sample mean and sample proportion to make the confidence interval for our population parameter. The same with confidence interval for two population, means and proportions. And we have gone through our hypothesis testing for one population and two population. Again, every single discussion relate to mean and proportion. Okay. Unlike our non-parametric statistic, we are no longer talking about means. Okay, we are no longer talking about proportion. Why, class? When we discuss about parametric statistics, we know that we assume the middle point, okay, measure of central tendency for the mean, okay, for the mean, that would be x bar, it will be equal to the median, okay, and the same with the mode. Okay, we assume this will be the case when we have normal probability and normal distribution, such as this one. Okay, that's why we choose mean, because out of the three measures, mean, median, and mode, we know mean would be representing the whole data that we have under our data set. Okay, that's why we choose the mean. Now, for non-parametric statistics, since we are talking about non-normal data, okay, so we are talking about non-normal data. When we say non-normal data, what do we mean by non-normal data? Our data can be distributed with flat distribution, or peak distribution, or skewed distribution. For example, we have right skewed, and it could be left skewed distribution. Okay, so when you have this particular kind of distribution of your data, you cannot use parametric statistic. So you have to choose non-parametric statistic for you to make inferences for your population. Okay, so for one population, we are going to use sign test. For two population, we are going to use man-with-me test. And unlike parametric statistic, we are using the population mean, sample mean and sample proportion. In non-parametric statistic, we are going to use the median. Okay, why median? Can someone still remember why median is the most suitable measurement for measure of central tendency if it is not normal distribution? Can someone still remember the reason why we use median instead of mean and mode, for example? Can you still remember? Class, in chapter 1, our discussion in chapter 1. Why we choose median if we have non-normal data? Class? No one remember? Class? Yes or no?
No,
No.
madam.
No, you don't remember? Because median is the only measure of central tendency that is not affected by the value of the minimum value or the maximum value. Okay, so it would be good to use the median if you have your data is not normal. Okay, because it is representing the 50th value, the middle value, regardless of what will be the minimum data or the maximum data. Okay, so if we are talking about mean, if you have very large data, your mean will be affected by this particular big data, or it could be the smallest data that may affect your measure of central tendency. Okay, now remember non-parametric statistic for non-normal data, and we are going to use the median, okay, for our hypothesis testing. So now class, when we said about sign test, non-weakly test, we are talking about hypothesis testing. Okay, that's why this arrow shows hypothesis testing for one population and hypothesis testing for two population. Okay, let us look at the first method. Hopefully we can finish our class early, okay, regardless of the hassle at the beginning. Now, for one population, we call it sign test. There will be still 5 steps for you to perform the sign test. Now, the first step would be identify the claim and state the hypothesis. Okay, so you need to write down what will your hypothesis, the null and alternative, and out of the two, you can highlight which one would be your claim. And for the type of testing that we may have, as usual, you can have two tail tests, left tail test, and right tail test. Okay, so you have null and alternative for your hypothesis. And for two tail test, okay, for this one class, M refers to median. Okay, so M naught refers to hypothesized median value. Okay, so this will be given that you need to test in your example of questions. Okay, so for two tail tests as usual, you will have equal to for the noun and not equal to for the alternative. And for left tail test, you have this symbol for the alternative, and for right tail test, you have this for your alternative. Now, okay, so you can see for the second step, you need to find how many data, how many will give you plus sign, negative sign, and how many from your data will give you zero value. Okay, so we will see this afterwards. Okay, and for the second step, you will have to go through the test statistic. You need to find the test statistic known as T. Okay, and you will have to depend on what type of test that you are doing. If you are doing two tail tests, okay, so this is how you choose your K. If you are using your left tail test, you are going to use your plus sign. If you're talking about right tail test, you're going to use your negative sign. So how do we do this? Okay, let us just forget about this step, and hopefully by the time I discuss the example, you can glance through how this step is being performed one by one. Okay, so let us look at the example, because if I were to talk about this one, it would be just a theoretical, what we call theoretical thing, so it would be difficult for you to describe. Okay, why don't we just do the example 3.13? Okay, so you can turn to your page of your textbook on page 102. Now, class, please remember, non-parametric statistic, the last part is actually the most simplest, what we call hypothesis testing, and you should have, if you are given the question of this particular question, you need to get 100% out of the given mark. Okay, otherwise it would be not good for you, because compared to the parametric test statistic, it will be much more things that you need to think of. Okay, so for example, example 3.13, an owner of a souvenir shop hypothesizes that the median number of items sold per day is 40. So you can identify from the given sentence. So you can imagine that this is your hypothesized median. Okay, hypothesized median value. A random of 20 days. Okay, so what this mean? So you are going to see 20 data given in your question. Okay, so a random of 20 days yield the following data for the number of items sold each day. So this data represent the number of items sold for 20 days. Okay, for example, for the first day, the owner sold about 18. Second day, for example, if second day is 43, so second day the owner can sold about 43 items. And the last 20th day, the owner sold about 52 items. So these are the number of items sold for 20 days. Now, okay, at alpha 0.05, test the owner hypothesis. Okay, so you need to test whether the owner hypothesis is correct or not. So you have to use this data using the sample evidence, whether you have enough evidence to support the claim or you need to reject the claim. Okay, so let us see how we can solve this. So the first step, okay, so the first step would be setting the hypothesis statement. Okay, so null hypothesis would be, okay, median equal to 40. Okay, alternative median. Okay, now look at the statement. An owner of a souvenir shop hypothesizes that the median number of items sold per day is 40. So is 40 means this is the claim. And of course, when you are testing equal to, then the alternative would be not equal to. Okay, so that would be your first step. Okay, for the second step, you need to find the critical value. Okay, sorry, you need to compute the test statistic. Okay, there will be a bit confusion in your what we call in your textbook, because the second step will be obtaining the uh, critical value. Okay, so let us just follow the textbook. Okay, because the second step should be test statistic, but it's okay lah. We follow the textbook. The second step would be obtain the critical value. Critical value CV. Okay, when we talk about critical value, definitely you are going to relate that to your alpha 0.05. Now, since we are talking about two-tailed test, okay, so take note that this is a two-tailed test. Okay, so the way you find your critical value would be a bit different. So you have to remember your alpha would be divided by 2. So you will get 0.025. Okay, so that will be your alpha. Now, okay, so for your critical value alpha 0.05, so you will have you need to find your n. What is your n in this case? N is no longer the number of samples given to you. Okay, so your n would be depending on your sign of your plus, minus, and zero sign. So how do we find this? The question mark. So how do I know which one is positive, negative, and zero? Now, okay, look at the step. It says that compare each item, each data with the hypothesized median and not, and assign positive if the data value is greater than the hypothesized value, negative if it is less than the hypothesized value, zero if it is equal to the hypothesized value. So how do we find that? Okay, your line of what we call calculation will be your hypothesized value, that will be 40. So look at every data that you have in your data set. So begin with your 18. 18 and 40 will give you negative sign because it is located here. For example, 43 is somewhere here, so it will give you negative sign. Here it will give you positive sign. So whenever we look for our data, so 18 it will give you negative. Okay, 43 here it will be positive. 40 exactly at the hypothesized value will give you 0. 16 will be at the negative. 22 negative. 30 negative. 29 negative. 32 negative. 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 Positive. Negative. Negative. 0. Negative. Negative. Positive. So from this, calculate the number of negative signs. So how many negative signs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have 15. What about positive sign? 1, 2, 3. You got 3. How many zero? You got 2. So if you add up all together, you got 20. Then you are correct. Then only you proceed with your n. So what is my n? N would be the number of plus n negative. So it would be from here regardless of 0. So n would be 15 plus 3. So that's why here your n is equal to 18. Okay, so your n is equal to 18. Okay, so from here you need to find what is your critical value. Okay, so here our critical value is known as our K. KCV based on alpha 0.025 and n equal to 18. Now look from your table of sign test. Remember, so if you can turn to your last page of your textbook, look for your sign test table. So I have provided my sign test table at the end of my slide. So if you look at your sign test table, you are talking about two-sided test. Okay, you are talking about two-sided test, and your alpha is 0.025. Okay, two-sided test. So look for alpha because we know that alpha over 2 is 0.025. Since you have two-sided test, just use your alpha equal to 0.05, which is this one. Okay, and your n is 18. For 0.05, 18. So this will be your KCV. Okay, so go back to your step just now. So your KCV is equal to 4. Okay, everyone okay at this point? Class?
Yes, madam.
Okay. Number 3, your next step would be once you have got your critical value, you need to compute your test statistic. Okay, test statistic as usual. Test statistic. Okay, your test statistic is given by uh, K. Okay, is given by K. So how to find K? Now, from this one, you know that negative sign, okay, you have negative sign is equal to 15. Okay, you have positive sign is equal to 3. Okay, now look at the step. How to find the test statistic? Okay, obtain the critical value. This part has been done. Okay, for test statistic, okay, for two-tailed test, K is the minimum number between plus and minus sign. So we look at this. We use this as our guideline. If you are dealing with left tail test, you are going to take So imagine you have your hypothesized value here. So you will have negative sign here, you have positive sign here. If you are talking about right field test, okay, right field test, it will be this way, right? So that's why you look at the negative sign. So if you are talking about left field test, so you will have this sign. That's why you look at plus sign. Okay. So for two-tailed test, you need to find the minimum between the plus and minus sign. So from here, okay, K is equal to minimum between okay 3 and 15. So you will be choosing 3 because it is the minimum value between 3 and 15. So K is equal to 3. Number 4, decision. So for the decision part, okay, so you will need to remember, okay, since test statistic, okay, K is equal to 3, okay, compared to your KCV is equal to 4 is less than, okay, so your decision will be reject now. Okay, so you can see from the step, make decision if KCV is K is less than or equal to KCV, then you will have to reject the null hypothesis. Otherwise, you will fail to reject the null hypothesis. So in this case, reject null hypothesis where it is your claim that you need to test. Okay, so this is your claim, and it seems that we have sufficient evidence to reject the claim. Now the conclusion. Okay, so in this case, okay, there is sufficient evidence okay, to reject the claim. What claim? The reject claim that the median number, okay, that the median number of items sold per day, okay, is 40 items, okay, at 5% significant level. Okay, if you wish to include the significant level. So the whole sentence after that the claim, okay, so it is referring to your claim that you are testing. Okay, class, any question so far? Any question for the example?
No,
If no
madam.
question, okay, thank you. If no question, let us do exercise 3.10. Okay, so for 3.10 and on page 103, okay, so please look at question 2. Okay, a random sample of 15 measurements of octane rating of a certain type of gasoline are as follows. So you are given the rating of octane, okay, for certain gasoline. So you have 15 readings altogether. Test whether the median of octane rating is greater than 98. So you can see that this is your hypothesized value, okay, and you have altogether 15 data, okay. So let us solve this one by one. Okay, so begin with your first step. That will be your hypothesis statement. So let me choose pen, blue pen. So your null would be, okay, median is equal to 98. Alternative, median is greater than 98. And this become your claim. Okay, second, okay. Second, if we follow the example just now, we find the critical value. Okay, critical value. Okay, our critical value, okay, will be our KCV of the alpha and your n. And to get our n, we need to analyze our data using the hypothesized value. So we are talking about 98. So this is the boundary between the value before and value after. Okay, so every data that is below the 98, you will get negative. Every value that above 98, you will get positive. Okay, so let us just uh, okay, just put everything nicely. So for the first one, 99 and 98, it will be positive. Second, 102, still positive. 99, positive. 105, 100.5, positive. 99.7, positive. 96, negative. 99, positive. 102, positive. 103, positive. 97, negative. 100.4, positive. Okay, then you have 98.9, positive. 98.3, positive. 98, 0. 101, positive. So out of this, your negative sign, how many? 2. Your positive sign, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 0, 1. Is it 15? Okay, 15. Okay, everything checked. Okay, from here, you will have your alpha is 0.05. So KCV for 0.05 and your n is based on what? You are talking about right tail test. Okay, right tail test. So let us look at the condition for right tail test. So if you are having right tail test, okay, your critical value would be, okay, your n is the number of sign plus the number of plus and the number of negative. So you will have how many? You will have n equal to 14. So 14, 0.05. Okay, look at your sign test table, everyone. Turn to your sign test table. So we are talking about one tail test. So we refer to our one tail test, one-sided test, and our alpha is 0.05, which is this one, and our n is equal to 14. Okay, equal to, okay, our KCV is equal to 3. Then go back, KCV is equal to 3. Number 3, find K. Okay, test statistic. Now, how to find test statistic? For right tail test, okay, we look at the negative sign. Right tail test, look at negative sign. How many of them are negative? So in this case, our K, okay, right tail test. So you are going to look at your K would be your negative is equal to 2. Okay, and number 4, decision. So since we have K is equal to 2 and KCV is equal to 3 and your KCV is greater than 3. Okay, so in this case, the same as what we have in our example, then our decision would be reject null hypothesis. Okay, so number 5, your conclusion. Okay, now what is our claim? Our claim is at the alternative, and yet we reject the null hypothesis, means that we have sufficient evidence to support our claim. Okay, so there is sufficient evidence to support our claim that the median obtained rating, okay, is greater than 98 at 5% significant level. Okay, class? Understood, class?
Yes,
Yes,
madam.
madam.
Okay. Okay, so remember class, if you are dealing with two-tailed tests, okay, if you are dealing with two-tailed tests, you are going to choose the minimum of the negative sign and positive sign. If you are dealing with right tail test, you are going to base on your negative sign. If you are dealing with left tail test, you are going to use the positive sign. So that will be easier for you to remember. And of course, for the decision wise, you have to remember if the KCV is greater than the K, if your critical value from your table is greater than the K, then it will be reject null hypothesis. So that will be everything about the sign test. So hopefully by having the two discussion of example as well as the exercise questions, I hope everyone can start doing the question for the sign test.